we have the flow diagram of the code, which demonstrates the logic of the code. So right here, if the resultant distance is less or equals than 30, the green LED will be on. The next situation is if the distance is less or equals than 20, the blue LED will be on. The other situation will be if the distance is less or equals than 10, then the red LED will be on. Right next to it, if the distance is less or equals than 7, the buzzer sound will be on. A constant sound will be on. I don't know if you guys can hear it. But the last situation will be if the distance is greater than 100 centimeters, the serial monitor will display a message that says out of range. So technically, this distance is measured in centimeters, and it measures the distance between the sensor and an object that is interfering between the sensor and the object, because the ultrasonic sensor sends waves, and if a object is between the line of travel of the waves, the object will cause those waves to bounce back to the sensor, and the time that it takes to travel from the object, from where the object makes the waves bounce back, that time will be translated into a distance, and that distance will be taken through this flow diagram, and it will display a result on the circuit. Right, so right here we have the code that basically has all the coding for the different situations. For example, if the distance is less or equals than 30, right here, the green LED will be on. Another statement will be if the distance is less or equals than 7, the buzzer will be on, and so forth. Right here is just the code to change the centimeter distance to inches, and everything is given right here. Is just this code basically displays the formulas and stuff to change the time that is being read by the ultrasonic sensor to distance, and this distance will be identified by the code, and then it will display a result on the circuit, which will be either the LED or the buzzer sound.
Right here we have our ultrasonic sensor with the echo and trigger pin, as well as the ground and power. And right here we have the 3 LED indicators that will indicate if the distance is too short, if it's too far away. And right here we also have the buzzer. As you can see, it makes a pretty loud sound. And right here we have our ground and power cables. And right here just the microcontroller. And as we can observe, the cables are directly connected to the analogic digital pins. So right here, as we described in the code, if the distance is too far, it won't record any data. But as we start getting closer to the sensor, the light starts changing. So right here, it has green because it's a certain distance. We have blue, we have red, and as you get closer, if you pass 7 centimeters, it will make a sound. You see? And right here, you can observe the data that is being displayed on the serial monitor, so it changes as well. It's another way to observe and analyze the distance that has been measured. The distance can be measured in centimeters and inches, and as well as the time lapse. Alright, so using this little toy as a example to demonstrate how useful are these ultrasonic sensors. They can be used in real vehicles to in the back of the car, just to see when you're parking. For example, if you're parking and you're getting too close to hit something, it indicates that you're too close, you know.